Able barriers don't look strong. 3 thin steel cables mounted on light posts, often placed in wide medians. Compared to concrete or steel guardrails, they seem almost insignificant. But in crash performance, they behave very differently. And in many scenarios, they outperform both rigid and semi-rigid systems. One system mechanics, cable barriers are tension-based systems. The cables are pre-tensioned between anchor terminals. This initial tension is critical. It allows the system to immediately engage when a vehicle makes contact. At impact, the vehicle doesn't hit a rigid surface. It engages a flexible system that starts to deform almost instantly. 2. Impact behavior. As the vehicle pushes into the barrier, the cables begin to stretch. The posts progressively yield or release, and the system redirects the vehicle while continuing to absorb energy. This process happens over distance, not at a single point. That's the key difference. Instead of a sudden deceleration spike, you get a gradual reduction in the speed. 3. Energy dissipation. From an engineering perspective, cable barriers increase the impact duration. An increasing impact duration reduces peak deceleration. This is directly linked to lower injury severity. The kinetic energy of the vehicle is not stopped abruptly. It is dissipated through cable elongation, post-deformation or detachment, friction and redirection. 4. Deflection, the critical parameter. But this performance comes with a cost, high deflection. During impact, the system can deflect several meters. This is defined as working width in standards like EN 1317. If there is insufficient space behind the barrier, the vehicle may strike an obstacle, override the system, or experience a secondary impact. In those cases, the safety benefit is significantly reduced. 5. Installation sensitivity. Cable barriers are highly sensitive to installation. Key parameters include cable tension, post spacing, anchor system performance, ground conditions. Improper tension or degraded anchors can reduce system effectiveness. Maintenance is also critical. After impact, tension must be restored. Otherwise, the system may not perform as designed in the next crash. Where they perform best, cable barriers are most effective in wide medians, high-speed roads, areas with a high crossover crash risk. But they are also increasingly used in complex mountain environments where impact severity and loss of control become critical factors. For example, this type of barrier has been implemented on sections of the Transfăgărășan highway, often considered one of the most beautiful roads in Europe. In these conditions, the goal is not just containment, it's energy management. Because when vehicles leave their path on high-risk geometry, the way energy is absorbed can make the difference between a recoverable incident and a severe crash.